Okay. So we are. Can you see the screen?
Yes, sir.
Okay.
Yes, sir.
In the previous lecture, we discussed what is the subgroup generated by the subset of a group. Okay. What is the definition? The smallest subgroup of G containing M is called the subgroup generated by M and will be denoted by curly M. Okay, this is nothing but the smallest subgroup of G in which M is contained. Okay, then that subgroup is called as subgroup generated by this set M. Okay, what is the notice there? If M is any subset of a group G, then the smallest subgroup of G containing M is exist and is unique. That the smallest subgroup is unique. म्हणजे only एकच सबग्रुप असणार. ओके, एकापेक्षा जास्त सबग्रुप नसणार. इज युनिक. सो द नेक्स्ट पॉइंट इज दॅट कॉम्युटेटर सबग्रुप. इट इज ऑल्सो कॉल्ड एज डिराइव्ड सबग्रुप. ओके, जेव्हा मी एक्सप्लेन करत जाईन तेव्हा तुम्ही नोट डाउन करत चला. ओके, द डेफिनेशन ऑफ कॉम्युटेटर सबग्रुप. द नेक्स्ट पॉइंट इज कॉम्युटेटर सबग्रुप or it also called as derived subgroup. Let's see what is the definition of the commutator subgroup or derived subgroup. Look at here. Let G be a group. Define one set U such that A, B, A inverse, B inverse, where A and B belongs to G, is known as commutator set of a G. Okay, this is the commutator set of G, not commutator subgroup. It is the commutator set of G. Then the subgroup generated by U, and U is called commutator subgroup of or derived subgroup. Okay, derived subgroup of G. Okay, look at here. Here U is the set of the form A, B, A inverse, B inverse, where A and B belongs to G. Take any two elements from element G. Okay, suppose A and B here belongs to G. Then we have taken A, B, A inverse, B inverse. Okay, whatever the composition or product of this term, okay, then it will be the element of U. Okay, so any element of U is in the form of A, B, A inverse, B inverse. Okay, if you have given, they have given you, it is the commutator set, then any element from the commutator set is in the form of A, B, A inverse and B inverse. Okay, is known as commutator set of G. Then the subgroup generated by U, it's called as commutator subgroup or derived subgroup. In the previous lecture, we seen that what is the subgroup generated by U? Subgroup generated by subset. What is the definition of subgroup generated by set? It is the smallest subgroup containing U. Then that subgroup is called as commutator subgroup. This subgroup generated is nothing but the smallest group in which U is contained. Okay, understood?
Yes, sir.
म्हणजे कोणताही एलिमेंट यू मधला कोणताही एलिमेंट कसा कोणत्या टाइपचा असेल त्याचा फॉर्म कसा असेल ए बी ए इनवर्स बी इनवर्स ए अँड बी बिलॉंग्स टू जी. कोणतेही दोन एलिमेंट घ्यायचे आणि त्याच्यापासून ए बी ए इनवर्स बी इनवर्स हा जो काही प्रोडक्ट येईल तो कशामध्ये जाईल यू मध्ये जाईल. ओके, सो and the subgroup generated by U is nothing but the smallest group in which U is contained. Then that group is called as commutator subgroup or derived subgroup of G, and it is denoted by G dash. Okay, that commutator subgroup or derived subgroup is denoted by G dash. Okay, note, if X belongs to G dash, then X in the form of A, B, A inverse, B inverse for some AB belongs to G. Look at here. If any element which is belongs to G dash. Okay, but G dash is nothing but commutator subgroup of G or derived subgroup of G in which U is contained. Okay, so but in the every element in the U is which is in the form A, B, A inverse, B inverse. Okay, so every element X belongs to G dash, then X is in the form of A, B, A inverse, B inverse. For some A, B belongs to G. Okay, or X is equal to Y1 into Y2 into up to Yn for each Yi belongs to D. How it is? ये समझते हैं x is equal to y1 into y2 into up to yn for each yi belongs to u. कळते का हे yi कसं आलं? Look at here. Suppose take y1. y1 belongs to u. It means that y1 is in the form of a b a inverse b inverse. Okay. Suppose y2 belongs to u. So y2 is also in the form of a1 inverse. Suppose that elements are a1 b1. Okay. So y1 may be y1 is in the form of y2 is in the form of a2 inverse a2 b2 a2 inverse b2 inverse. Okay, similarly up to yn is in the form of an bn an inverse bn inverse. Okay, but the u but the subgroup generated means by what is the meaning of this subgroup generated by u is means that the smallest subgroup containing u. Hence this all these terms a1 b1 a1 inverse b1 inverse for y1 for y2 a2 b2 a2 inverse b2 inverse up to yn, the product of all these is going to g dash. Okay, why? Because by closure property the product of this y1 y2 up to yn which is equal to x is the element of g dash. कळते का?
Yes, sir.
हा एखादा एलिमेंट जर जी डॅश मध्ये असेल तर तो त्याचा फॉर्म कसा असेल त्या एक्सचा एलिमेंट ए इंटू बी इंटू ए इनवर्स इंटू बी इनवर्स और x is equal to y1 y2 up to yn where this all yi belongs to u. Okay, या ए बी ए इनवर्स बी इनवर्सला समजा y म्हटलं y1 म्हटलं हा इथं y1 आला. समजा a1 b1 a1 इनवर्स b1 इनवर्स याला y2 म्हटला तर हा कशातला आला इथे आला y2 is belongs to u आला. Okay, but by closure property of group this all the product of these terms which is equal to x belongs to g dash because g dash is the smallest group containing u. Okay, understood?
Yes, sir.
Yes, sir.
काही डाऊट आहे काही?
No, sir.
म्हणजे आता तुम्हाला जर एखादा एलिमेंट दिला सपोज यू हॅव गिवन we have given x belongs to g dash, then the x is in the form of a b a inverse b inverse or x is equal to y1 y2 up to yn where for each yn yi belongs to u. Okay, okay, now the next point is one more theorem is there. Okay, let G dash be the commutator subgroup of a group G. Then G is abelian if and only if G dash is equal to singleton E, where this E is belongs to G, that is identity of G, group G. Okay, we have statement if G dash be the commutator subgroup of a group G, then G is abelian if and only if G dash belongs to E. So what we have to prove in the first part, we assumed G is an abelian group. Okay, and we have to prove that G dash is equal to singleton E. And in the second part, we have to prove that assuming G dash is equal to singleton E, then we have to prove G is abelian. Okay, suppose let's see the proof. Let G be a group and let U is equal to A inverse B inverse, where AB belongs to G. Okay, if G dash is the commutator subgroup of G, commutator is nothing but derived. Okay, both are same. Commutator subgroup of G, then G dash is the subgroup of G generated by U. This is U. Okay, not D here. This is the U is there. Okay, if G dash is the derived subgroup or commutator subgroup of G, then that G dash is generated by U. Generated by U, it means that this U, the smallest, this is the smallest subgroup of G in which U is contained. Okay, that is G dash is the smallest subgroup of G containing U. Okay, इथपर्यंत काही अडचण आहे का?
Excuse me, sir. Sir, can you explain this by example?
एक्झाम्पल तर आता नाही आहे काय, उद्या घेऊन दाखवू दे, नेक्स्ट लेक्चरला दाखवू. ओके,
Okay, sir.
कॉम्बिनेटर सबग्रुप घेऊन त्याला जनरेट जी डॅश सी डिराइव्ड सबग्रुप दाखवतो. ओके, look at here. G dash is the smallest subgroup of G containing U. Okay, suppose in the first part, suppose G is abelian, then we have to prove that G dash is equal to singleton E. Okay, so consider A inverse B inverse, which is equal to A B inverse A inverse. Why we can write like this? Because G is the abelian, so we can commute this element A inverse and B inverse. Okay, A inverse and into B inverse is nothing but B inverse into A inverse. Okay, which is equal to A is equal to B inverse A inverse, which is equal to, but B into B inverse is nothing but E, where E is the identity of G. So A inverse, which is equal to A into A inverse, which is equal to E. Hence, thus the U consists only one element, that is singleton E. Okay, this G dash is nothing but the smallest subgroup of G containing U. Okay, G dash म्हणजे काय? G dash म्हणजे तुमचा स्मॉलेस्ट सबग्रुप जनरेटेड बाय U आहे. ओके, ते आपल्याला प्रूव्ह करायचं. G dash इज इक्वल टू सिंगलटन E. समजा मी U मधले प्रत्येक एलिमेंट कोणत्या फॉर्म मध्ये असतो? A इनवर्स B इनवर्स म्हणून हे कन्सिडर केलेलं आहे. ओके, सो बट A इनवर्स B इनवर्स काय आलेला आहे? ते सिंगलटन E. म्हणजे तुमच्या U मध्ये फक्त कोणता एलिमेंट आहे? Singleton E. Thus U consists only one element, which is singleton E. But the smallest subgroup of G containing singleton E कोणता आहे? ओके, काय विचारलं मी? स्मॉलेस्ट सबग्रुप ऑफ G containing singleton E. कोणताही एक ग्रुप आहे. Suppose G is any finite or infinite group, and suppose you have M is the set singleton E. Then what is the smallest subgroup of G containing M? Anyone tell me?
Singleton E.
Is that पासून जनरेट झालेला आहे म्हणजे काय? U ला कंटेन कर. व्हॅल्यू काय आलेली आहे का? कारण
No, sir.
Dash is equal continuous dash continuous element from by this
No, sir.
No, sir.
No, sir.
No, sir.
we are going to next theorem. Okay. This one more important theorem is there. By using this theorem, we can solve some more solvable group. हे theorem important आहे, नीट लक्षात द्या. Let G be a group and G dash is the derived subgroup of G. Then prove that. First, we have to prove that G dash is normal in G. Second one, G upon G dash is abelian. Third one, if n is normal in G, then G by n is abelian if and only if G dash is contained in n. Okay, G dash is the subset of n. Okay, काय प्रूव्ह करायचं आपल्याला? G dash is normal in G. G by G dash is the abelian. N is the normal subgroup of G. G by N is abelian असेल तर काय प्रूव्ह करायचं? G dash is contained in N. Okay, let's see the proof of the first statement. Given that G is a group and G dash is the derived subgroup of G, we have to prove that G dash is the normal in G. Okay, for this one we have to prove that G dash is normal in G. Okay, so what we have to prove? Take any element x belongs to G and C belongs to G dash. The x C x inverse belongs to G dash. Okay, समजा h हा समजा सबग्रुप आहे तर तुम्हाला नॉर्मल दाखवायचं असेल तर काय करतो आपण? x h x inverse belongs to h ना?
Yes, sir.
हा, एखादा ग्रुप नॉर्मल दाखवायचा असेल तर आपण x h x inverse belongs to h करतो. Similarly, here if G dash, we have to prove that G dash is normal in G. That is to prove that for all x belongs to G and C belongs to G dash, x into C into x inverse belongs to G dash. Then the G dash is automatically normal subgroup of G. For this one, considering x C x inverse, which is equal to x C x inverse into E, which is equal to x C x inverse, then we can write E is as a C inverse into C. Okay, then by using associative property in G, x C x inverse C inverse into C. Okay, now look at here. We take an x from G and C from G dash. Then x C x inverse C inverse belongs to G dash. Okay, why? Because G dash is the derived subgroup of G. Okay, so x C x inverse C inverse belongs to G dash and C belongs to also G dash. Okay, C is the also the element of G dash and x C x inverse C inverse also belongs to G dash. Hence, the x C x inverse, which is equal to x C x inverse C inverse into x belongs to G dash. By which property? Anyone knows by which property of group this element x C x inverse belongs to G dash? कोणत्या प्रॉपर्टी नुसार तो एलिमेंट G dash मध्ये गेलेला आहे?
Sir.
Yes, very good. Look at it. x C x inverse C inverse हा एलिमेंट म्हणजे काय असणार? तुमच्या कॉम्युटेटर सबसेट मध्ये असणार. ओके, कॉम्युटेटर सबसेट. पण G dash काय तुमचा? कॉम्युटेटर जनरेटेड बाय कॉम्युटेटर सबसेट, हो की नाही? कॉम्युटेटर सेटने तुमचा G dash हा जनरेट झालेला आहे. काय म्हणजे G dash काय तुमचा? Smallest subgroup containing U. Suppose that commutator subgroup is U. So this element x C x inverse C inverse belongs to U, but U is contained in G dash. It implies this element x C x inverse C inverse belongs to G dash. But we have always already C belongs to G dash. Okay, we have C belongs to G dash. This is belongs to G dash and C also belongs to G dash. The product of these two must be belongs to G dash because G dash is the subgroup. Okay, hence, but what is the value of this one? X C x inverse C inverse into C is nothing but x C x inverse. Hence, here x C x inverse, which is equal to x C x inverse C inverse into C belongs to G dash, which implies that x C x inverse belongs to G dash. It implies G dash is normal in G. Okay, any doubt? बघा, डाऊट आहे का बघा, लिहून घ्या.
No, sir.
नोट डाऊन करतायत ना?
हो सर.
एनी डाऊट? बघा, पुन्हा चेक करा. ओके, एनी प्रॉब्लम, एनी डाउट? कोणते स्टेप समजले नाहीये? Now the next statement, we have to prove that G by G dash is abelian. Okay, G by G dash is the abelian group. We have to prove that. Okay, every element from this factor group is in the form of G dash A, where this A belongs to G. Okay, factor group चा element हा कोणत्या टाइपचा असतो? G dash into A, H A माहिती आहे ना, H A, where A belongs to G. If G by H is the factor group, okay, then every element of that factor group is in the form of HA, where A belongs to G. Here, G upon G dash. Can we define like this G upon G dash? हे define करू शकतो
Yes,
का
sir.
आपण? Why?
Yes, sir. Because
Why?
G
Why?
dash is normal in G.
Very good. G dash is normal in G. Hence, we can define this group, factor group. Okay, so every element from this group, factor group, is in the form of G dash A, G dash B. Okay. Let G dash A and G dash B belongs to G upon G dash, where A and B belongs to G. Okay, we have to prove that this one is factor group. Okay, for this one, we assumed that this factor group is abelian. हे प्रूव्ह करायचं आपल्याला. आणि या ग्रुपची आयडेंटिटी काय? या फॅक्टर ग्रुपची आयडेंटिटी
G dash.
व्हेरी गुड. जो नॉर्मल सब ग्रुप असतो त्या फॅक्टर ग्रुपची आयडेंटिटी असते. नाउ फॉर दिस वन वी assumed that, consider that G dash A into G dash B whole bracket multiply with G dash B into G dash A inverse. Okay, why we are going to consider this? शेवटी कळेल तुम्हाला. Look at here. G dash A into G dash B is nothing but G dash AB. Why? Since we have HA into HB is equal to HAB. Similarly, G dash BA inverse. Okay. For this one, we implies that G dash AB BA inverse. Okay, which is equal to G dash AB BA inverse is nothing but A inverse B inverse. Okay. So, which is equal to, look at here in the bracket. If nx is equal to x or ha is equal to h, here we assume that hx is nx is equal to n, which implies and implied that this x belongs to n. Okay. Okay, stay result I direct. We have here a inverse b inverse belongs to G dash. It implies that G dash AB in A inverse B inverse is equal to G dash. Okay, from using this result, we have G dash AB A inverse B inverse is equal to J dash, which is nothing but identity of that factor group. Okay, this one. Okay, so we have G dash A into G dash B is into G dash B into G dash A inverse whole bracket inverse, which is equal to G dash. But G dash is the identity of this factor group, G upon G dash. Hence, A into B inverse is equal to E असेल, समजा identity असेल. So what we can say that A is the inverse of B or B is the inverse of A. Okay. कोणतेही दोन एलिमेंट असतील, ए बी इनवर्स इज इक्वल टू ई आला असेल आयडेंटिटी एलिमेंट, तर आपण काय म्हणतो तिकडे ए हा बीचा इनवर्स आहे किंवा बी हा ए चा इनवर्स आहे. ओके, इथं आयडेंटिटी काय तुमची जी डॅश आहे, आयडेंटिटी एलिमेंट आली. मग काय म्हणू शकतो याच्यावरून आपण, हा एलिमेंट जी डॅश बी इंटू जी डॅश ए इनवर्स हा इकडचा राईट हँड साईडचा जो एलिमेंट आहे तो लेफ्ट हँड साईडच्या प्रोडक्टच्या लेफ्ट हँड साईडचा काय इनवर्स आहे. Okay, so we can write G dash A into G dash B is equal to G dash B into G dash A inverse of inverse. Okay, but inverse of inverse is nothing but itself element, G dash B into G dash A. Okay, hence G dash A into G dash B is equal to G dash B into G dash A. Hence G by G dash is the abelian group. कळतंय?
Yes, sir.
आयडेंटिटी काय त्याची जी डॅश आहे, बट ए बी इनवर्स इज इक्वल टू ई असेल, वी कॅन से दॅट A is the inverse of B inverse, or AB is equal to A into B is equal to E असेल तर काय म्हणतो आपण A is the inverse of B or B is the inverse of A. Similarly here G dash A into G dash B into whole bracket is the inverse of G dash B into G dash A. Okay, from this one we can write like this. हा याचा इन्व्हर्स म्हणा किंवा हा याचा इन्व्हर्स म्हणा, दोन्हीचा अर्थ एकच होतो. Hence we get G upon G dash is the abelian group. Any doubt? हे असं येतं त्यांचं प्रोडक्ट G dash येतो म्हणून हे कन्सिडर केलेलं आहे इकडे. कळतंय? एक्झामच्या वेळेस तुम्हाला लिहिताना तुम्हाला हे कळायला पाहिजे कन्सिडर काय केलंय आपण. येणार आहे म्हणून कन्सिडर करा. डाउट?
No, sir.
Third statement. Let n is the normal in G and G by n is abelian. So that dash is contained in dash is nothing but derived subgroup of. Suppose we have arbitrary any n is normal in G, G by n is abelian. We have to prove this dash is contained in this dash is the subset of n. For this one, consider na into nb is equal to nb into na. Why? Because G dash upon n is abelian. So the element of G by n is in the form of na, nb. This G by n is abelian group. You can write like this: na into nb is equal into na. Which implies that na into nb, this element to the left side by post multiplying by inverse. Okay, left side ला येत नसतो एलिमेंट कोणताही ते काय करतो त्यासाठी आपण पोस्ट मल्टिप्लाय करतो आणि त्याच्या इनवर्स ने a na into nb into nb into na होल ब्रॅकेट इनवर्स. इथे काय येणार मग राईट साइडला आयडेंटिटी काय या ग्रुपची g/n ची okay, which is equal to n. Hence, but na into nb is nothing but nab. nb into na bracket is equal to nb to n. Hence, nab a inverse equal to because ha into hb is equal to hab. Okay, implies that ab a inverse b inverse belongs to n. Implies that ab a inverse b inverse. How HA is equal to H, then A belongs to H. Okay. Okay. A B A inverse B inverse belongs to, means A B A inverse B inverse. त्यात असणारा एलिमेंट तुमच्या सिन्स G dash मध्ये असणार आहे. Why? Because G dash is the commutator subgroup. Hence, it is the smallest subgroup generated by U. But every element in the form of every element of U is in the form of A, B, A inverse, B inverse. Hence, this element to G dash. Already हा element तुमचा G dash मध्ये गेलाय कुठे तुमचा G dash मधला element मध्ये गेलाय. Implies that G dash is this n. Any doubt? बघा चेक करा.
No, sir.
प्रत्येक स्टेप करेक्ट आहे का पहा. We go forward.
Yes, sir. Yes, sir.
Conversely. Now suppose dash is contained in n. N is normal in so that G by n is n. G by n is in the theorem, and if and only if. First one, this one we have to dash is sufficient. Next, in the second part, we have assumed that dash is contained in n, and we have to prove that G by n is abelian. Assuming G dash contained in n and n is normal subgroup, we have to prove that G is abelian. Conversely, suppose G dash is contained in n and n is normal in G, we have to prove that G by n is abelian. Reverse step घ्यायचा. Every element of G dash is in the form of A, B, A inverse, B inverse. Why? This G dash is the commutator subgroup, derived subgroup, generated by commutator set U. The element in U is in the form of A, B, A inverse, B inverse. Hence, this element is going to G dash. That is, G dash is contained in here. Dash is contained in N. Take here G dash, not G1. Okay. G dash. Here G dash is contained in N. Hence, this element goes in N. A, B, A inverse, B to N. Implies that N, A, B, A inverse, B inverse is equal to 1. Why? Because X belongs to H. Then Hx is equal to H. By using that property, N, A, B, A inverse, B inverse belongs, which is equal to N, A, B into N, A inverse, B inverse is equal to N. Implies that N, A into N, B, N, B, A inverse is equal to N. सगळ्या प्रॉपर्टी यूज करत जायच्या, त्याच ह्याच रिव्हर्स स्टेप घ्यायच्या, वर घ्यायच्या. Plus that NA into NB, which is equal to NBA. By post multiplying to step by NBA, we get identity element and we get N into BA equal to NA into NB equal to NBA into NA. Hence, every element of G by N is in the form of NA and B. Here we get NA into NB is equal to NB into NA. Hence, G by N is abelian. So this is the proof of the doubt.
No, sir.
काय अडचण आहे का विचारू शकता. ओके, लिहून घेताय ना तुम्ही. एकदा वाचा तरी पुन्हा बघा, चेक करा ते अडचण असेल. Note that here is the group and G dash be the derived subgroup of G. All the statements. One, G dash is not G by G dash is abelian, is normal in G, and G by N is abelian if and only if G dash is contained. And only if म्हटल्यानंतर प्रूव्ह करायचे, दोन्ही स्टेटमेंट प्रूव्ह करायचे. Part and sufficient. Only part and if part, दोन्ही प्रूव्ह करायचे. अडचण?
No, sir.
Next point of our syllabus is solvable group. Solvable group. Definition of our. Okay. G is the group if there exists a finite sequence of subgroup of G that singleton E, which is equal to H naught, normal in H1, normal in H2, which is normal in N, equal to G, factor group Hi plus 1 upon Hi, abelian group. For all I, the group is known as solvable group. Series is referred as solvable series. Here, what is the difference between solvable series and composition series?
Factor group is abelian and in composition series factor group is simple group.
ना अजून अजून एक डिफरन्स आहे काहीतरी.
Primer group.
हो अजून एक डिफरन्स आहे काहीतरी. हे करेक्ट आहे. HI plus 1 upon HI is abelian here and in composition series HI plus 1 upon HI or HI into HI upon HI minus 1 काही घ्या तोच येईल. नोटेशन आहे. तिकडे काय येईल सिंपल येईल. इकडे abelian येईल.
कंपोजिशन सिरीज मध्ये मॅक्झिमल नॉर्मल सबग्रुप असतात, इथं नॉर्मल सबग्रुप आहेत.
व्हेरी गुड. तिथे मॅक्झिमल नॉर्मल आहे. तो इन बिटवीन H0 and H1 तिथे कोणीही मध्ये येणार नाही. H0 is only maximal in main difference. जर ठेवून अभ्यास केला तर इझी जाईल तुम्हाला. ओके. एखादा ग्रुप जर सॉल्वेबल आहे म्हणजे आपण त्याला काय अज्युम करायचं लगेच एक सॉल्वेबल सिरीज आहे plus 1 upon HI plus 1 upon HI is the abelian group आहे. हेच अज्युमच करायचं. त्यांनी सॉल्वेबल दिलं म्हणजे की हे एक सिरीज त्याला एक्झिस्ट. The definition of solvable group is a group there exist म्हणते. कोणताही एक जरी असेल तरी चालेल आपल्याला. 2 येतील 3 येतील 4 येतील किती येतील माहिती नाही. एक्झिस्ट म्हणजे finite sequence of subgroup of G such that not is not factor group HI plus 1 of HI abelian. Okay. I running from 0 to n minus 1. And the group is known as solvable group and the series is referred as solvable. Next definition is काय doubts आहेत का याच्यात? मला काही समजलेलं नाही definition. Yes or no?
No sir.
Okay. We will move for next point. The nth commutator subgroup. This is the one more point is there. Important point is there. Okay. Nth commutator subgroup. Let G be any group for any positive integer n. We define nth derived subgroup of G and written as G raised to n. Okay, Gn as follows. Okay. So G dash or G1 is the derived subgroup of G. Okay, we know that G1 or G dash the derived subgroup of G. So every element of this G1 is in the form of A, B, A inverse, B inverse, where AB belongs to G. Okay. Now look at here. The second derived subgroup of G, G2, G raised to 2 is nothing but second derived subgroup of G, which is equal to G1 raised to 1. Okay. म्हणजे हा G2 कोणाचा derived subgroup आहे? G1 चा. Okay. That is G second derived subgroup of G. म्हणजे हा G2 हा derived subgroup आहे G1 चा, but हा G2 second derived subgroup कोणाचा आहे? G चा आहे. Okay. Similarly, G3 is the derived subgroup of G2. It means that it is the third derived subgroup of G. Similarly, Gn is the derived subgroup of G raised to n minus 1, which means that it is the nth derived subgroup of G. Okay. Here, look at here. G dash is nothing but G1, G2, G3 up to Gn. मग G2 ची डेफिनेशन कसे असेल? Derived subgroup of second derived subgroup of G. कसा असेल? याच्यातले एलिमेंट कोणत्या फॉर्म मध्ये असतील? G2 च्या where suppose x inverse y inverse belongs to G2 where x and y belongs to G1. समजते? G1 मध्ये काय होतं? G dash मध्ये काय होतं सबग्रुप? G dash हा कुठला होता? कम्युटेटर सबग्रुप. If every element of G dash is in the form of A, B, A inverse, B inverse, where AB belongs to G, but every element of G2 is in the form of A, B, A inverse, B inverse, where AB belongs to
G1.
Very good. Similarly, every element of G3 is in the form of A, B, A inverse, B inverse, where AB belongs to
G2.
very good. तसं similarly काय असणार G raised to n पर्यंत. Okay. So these are the nth derived subgroup. These are the nth commutator subgroup of G. Example मला जर मिळालं तर मी घालेन, प्रयत्न करेन, बघेन. The group G is known as solvable group. Okay. एखादी सिक्वेन्स आली तुमच्याकडे, derived subgroup, and the derived subgroup झाली. Group G is known as solvable group. Exists a positive integer n such that nth derivative or derived आहे बरं काही, nth derivative नाही, nth derived subgroup of G is singleton E. Suppose here in this series e raised to n is equal to singleton E, then say that this G is nothing but solvable group. Okay, म्हणजे एखादा ग्रुप तुम्हाला सॉल्वेबल आहे हे प्रूव्ह करण्यासाठी काय करावं लागेल, हे तुम्हाला एक्झिस्टन्स दाखवायचं नाही तिकडे. काय exist a sequence like this in which the factor group हे प्रूव्ह करायचं नाही. काय प्रूव्ह करायचंय, nth derivative subgroup of G is e raised to n. Nth derived subgroup of G singleton E, then this series is called as solvable group. Okay, any doubt?
No, sir.
आता इथे नीट लक्ष द्या. One point is, if G1 the derived subgroup of G na, one is derived subgroup of G, means that G dash is contained in G. Okay.
Yes, sir.
Hence G1 is the subgroup of G. तो त्याचा सबग्रुप आहे, डिराइव्ड सबग्रुप आहे म्हणजे तो सबग्रुप तर असायलाच पाहिजे ना, डिराइव्ड का असू दे का नसेल. G1 सबग्रुप आहे म्हणजे तो डिराइव्ड सबग्रुप आहे म्हणजे सबग्रुप आहेच तो. Hence G1 is the subgroup of G, but G2 is the subgroup of which one?
G1.
G2 is the derived.
G1.
G2 is the derived subgroup of G1 म्हटलंय.
G1.
डिराइव्ड असेल तर सबग्रुप असतोच की, म्हणजे हा G2 कोणात कंटेन असणार, G1 मध्ये कंटेन असणार. कळते? म्हणजे G1 आणि G2 मध्ये मोठा कोण आहे?
G1.
G2 आणि G3 मध्ये मोठा कोण आहे?
G1.
G2.
G1 आणि G2 मध्ये G1 झाला. G2 आणि G3 मध्ये मोठा कोण आहे?
G2.
G2.
G2 मोठा आहे. G2 and G3 मध्ये. ओके, ऑर्डर कशी होत जाणार, डिसेंडिंग ऑर्डर, छोटे छोटे ग्रुप होत जाणार. ओके, शेवटी G रेस टू n काय यायला पाहिजे, सगळ्यात छोटा यायला पाहिजे, हो की नाही. हेन्स G रेस टू n जर सिंगलटन E आला त्या ग्रुपला म्हणायचा डिराइव्ड सबग्रुप, सॉल्वेबल ग्रुप. डाउट?
No, sir.
In the next lecture, we will see the theorem. Okay, G is the solvable if and only if nth derived subgroup. Okay, theorem we will see in the next lecture at 2:30 PM. बघूया कोणाला डाऊट आत्ताच्या लेक्चर मध्ये अडचण आहे, काही समजत नाहीये पॉइंट, सेमिनारची टॉपिक तयारी करत चला. सेमिनारची टॉपिक तयारी करत जा. ओके, मी दिसतोय सगळ्यांना?
हो सर.
हो सर. Yes, sir.
काही अडचण वगैरे आहेत कोणाला काही?
No, sir.
ओके, द नेक्स्ट चॅप्टर, नेक्स्ट लेक्चर
सेमिनार मध्ये क्वेश्चन विचारले जाणार का?
सेमिनार